All right, I want you to understand something about electrical generators in the context of the overall electrical grid, which means the grid is just our whole electrical power infrastructure in our whole country, okay? So if we say the grid is this line, okay, I'm only going to draw one line even though all this stuff is three-phase, okay? When I tie a generator into it, okay, all these generators get tied into the grid, okay, and they all contribute electrical power to power the entire grid, if that makes sense. Like every, power plant in every city and every town, right? They all get connected to the grid, okay? G is for generator, okay? Make sure you can see this. All right, so what I'm going to do right now, okay, this is the grid. What I'm going to do right now, and you're going to see it on the trainer, is I am going to connect a generator to the grid. It's not really the grid. I mean, it kind of is. It's our power supply, but we're going to pretend it's the grid. And I'm going to show you what power plant personnel need to be aware of when they are connecting a generator to the grid, or when you're paralleling two generators together. Okay, you can't just slap them together. You got to be, you've got to use some tools and know what you're doing. Okay, so let's come over here, and I want to show you. I've got a DC motor now powering an AC synchronous three-phase, you could call it generator or alternator, depending what term you like. It's the same thing. Well, alternator in the case of AC, but I just call it generator generally. So anyway, we got the three-phase electricity is coming out of the generator, okay, and it's going into something called a synchroscope, or a synchronizing module, which is right here, okay. Now, I'm going to attempt to set this down. And, yep, perfect. And now, well, actually, but before I do that, I want you to see how this is going to work. I'm going to crank up the DC, okay, and that's going to make the DC motor spin. And when that spins, it's coupled via a belt to the generator. So let's start this thing up a second. Right now, our generator is putting out it's only at 9 hertz. It's got to be at 60 hertz, and it's got to be at pretty close to 208 volts, which it's going to connect to, which is our grid voltage. So I'm going to crank this sucker up quite a bit. And now we're at 30 hertz, you can see. 32 hertz, 33 hertz. I got to be at 60 hertz. Let's go all the way up to 60. We are now generating three-phase electricity at, let's get up there, at about 60 hertz. We are generating three-phase electricity right now, okay? Now, you see our synchroscope, the lights, I don't know if you can see that, the lights are flashing off and on. That's not good. What the synchroscope does is the lights are on whenever there's a difference between us and the grid, okay, between our generator and the grid. We don't want there to be a difference. We want them to be the same, and this switch will sync us up to the grid, but we don't want to do it until we're the same, okay? I don't know if you can see that. So what I'm going to do is set you down a second, okay? You can see the lights on the synchroscope are, look at this too, okay? If I were not phased sequence, like if I were out of phase with the grid, watch what the lights would look like. They wouldn't all come on at the same time. Do you see how now? Let's see. If I go further away from it, let's see if you can see that. Hang on a second. Oh, try to get, if I get closer maybe. Do you see how they're not all coming on at the same time? That is not good. We for sure want them to all come on at the same time, because if they all come on at the same time, it means we're synced up as far as our phase 1 is the grid's phase 1. Our phase 2 is the grid's phase 2, and so forth, okay? So I want to switch two of the phases around so that they're So the lights are all coming on at the same time, okay? Now at least they're all coming on at the same time, but they're still not steady. Again, the lights are just an indication of something not being the same between us and the grid, okay? So I want to adjust this. I'm like right at 60 hertz right now. I really want to adjust this until those lights are so dim and not changing, okay? So if they're getting a little brighter. Oh, they are so close to being completely out right now that I'm going to go ahead and there, I synced up to the grid. It was not the smoothest ever, but it was fairly smooth because the lights were dim. Now this being a trainer, I'll show you what would happen if we try to sync up like this, okay? It's not going to be pretty. Did you hear that change? The generator has no choice. The grid is a lot stronger, and it will sync it up, but not without an amount of violence, if you want to put it that way. So we don't want to sync up when we have changing action going on here on our synchroniscope, okay? Because again, it'll do this. We don't want it to jerk like that, okay? So listen to how much calmer the action is. Once we get the synchroniscope to calm down. Oh, still blinking. Let's get it. Flawless, right? That was like textbook right there. The synchroniscope was showing no light whatsoever, no change whatsoever. Look at that, I synced up. I am now not synced up to the grid, but the synchroniscope looks good. So listen to the change when I sync up. Almost no change. Here we go. Almost no change, okay? That's how you want to sync up to the grid or sync up to another generator, okay? That's what this thing is for, the synchroniscope. So hopefully that made some sense. See you in the next one.